So today we're going to learn how we can build the binary search algorithm while using test-driven development. So binary search is one of the efficient algorithms to search on, for example, an array of integer, and we need to implement that using a certain algorithm that is actually dividing and conquer stuff. So we are gonna play around with the middle index and for example left and right index, and doing some loop to search a certain number on the array, and we are going to combine that using test-driven development. But before we dive into binary search itself, let's try to implement that searching logic using like a normal brute force searching first, so that we can refactor it later to the binary search approach. So without further ado, let's start. So let's open the Xcode project, and let's for now I'm gonna try the new Xcode project, and let's do it with framework here, and let's name this binary search. Okay, so let's save it somewhere and make sure we are good to go. Okay, let's build, and I believe it is built successfully. Alright, so we already have the test as well here. So what I'd like to do is make sure that test is running, but let's remove this one and let's make a failing test first. So we are going to make a failing test and hit Command U here, or we can just press this down. So let's wait, and hopefully the test is going to be failing, which is pretty good because it's the very first step of test-driven development. Okay, cool. So the test is failing. So what we can do is first we want to search using a normal logic. For example, search returns nil when not found. For example, when the search item not found. So what we want to do is, for example, we have the SUT, which is the program, and we want to search on in the array. The target number is, for example, I don't know, 7, let's say, and this one should return that number, and we are expecting that our result is equal to nil, or we could refactor that, assert nil here. Our result should be nil. So let's hit Command U again, and let's see if we have a failing test. Great, we have a failing. So the compiler is helping us. We need to create the production code, which is the program here, and we need to have the search method in array, and that array is the array of integer with the target of integer itself, and it is going to return an optional integer here. And for now, let's return nil to passing the test with the minimal amount of code. We still need to have an array, and we can specify it empty for now here, or in empty array like this. And let's go and hit Command U again, and great, we are successfully returns empty when the array is empty. Of course, we are going to commit here. Let's commit, and let's see what just we did. Search returns nil when not found. Okay, so of course it is going to be look silly because we are not doing anything, but we are going to improve our production code along with the test code. So that's the process of TDD. So let's increase our test cases. Before jumping into that, I noticed that we can refactor this one. I think should return nil when array is empty. Okay, cool. So we could commit again, rename a test here, and what else we can do is testing our search logic should return nil when not found. here. So for example, I will have another array here, and let's name it sample, and the sample is, for example, 1 or maybe 7, and I will have a result and the target. Okay, we can like change it to 1, and the result should be nil as well, because it is we are expecting that not found number in the array. So let's hit Command U. Okay, I believe we need to change the syntax here, and of course we need to change that argument as well. So let's hit and run the test, and the test is succeed. Okay, that's great. So let's commit again. When we are doing the search, returns nil when not found. Okay, cool. So we need another test cases, and for now our test cases is should return found number when found number on, for example, single array item. So we are trying to doing it one by one. So for example, we have a very similar test here. We need sample, and we are doing the found case here, so we can just using it 7 here, and we want to find the 7 number, and I'm expecting that the result is equal to the sample here, but it is the array, then we can move that into an array. So let's run the test, and I believe the program should fail somehow. So let's try again. Great, it is returning nil while we are expecting 7 here. So that's pretty great. So we can try to do some logic here. I'm going to do a brute force searching first. So when we are iterating through the number in the array, and if our iterated number right now is equal to the target, then we can just return that number here. So let's build that. So I missed this syntax here. Let's Command U again, and see, we have a green test here. So pretty good. So we can commit here. Search returns found number. Oops, what is this? Let me fix this a little quick. Okay, search returns found number when number is found. Okay, so we could increase our test case again. For example, maybe we have like another number, right? So let's copy the function name, and this one probably on multiple array or more than one item. So what we can do is we can copy the setup. For example, sample should be for now 7 only, and this should be an array, and result, I'm searching on the number 7 in that array, and the result I'm expecting my result is equal to the 7 here, because my sample is 7. And because of we are dealing with like more than one item, so we could increase our array here. For example, with this 1, 7, and 3 number in that array. Okay, great. We are having a green state right now, so we can commit here. Search should return found number when found number on more than one array item. Great, right now we are really good. One thing we can do, we can improve this by getting rid of this is statement. We can like using where clause here, where the number is equal to target, and we can just return that number. This is part of the test-driven development. We can refactor safely and run this again, and we still in a green state. Maybe we can commit here using where clause instead of if statement. Okay, so I think we are good to go. We have like good suite of tests, right? So we can try to refactor this search implementation into binary search. binary search, or we could just rename using right click, refactor, and rename. Can rename that into binary search. Okay, let's run this again. Let's improve the test naming. Let's commit with the message of improve the test naming. Oh, sorry, improve the function naming in preparation for binary search. Cool. So what we can do here. So how does this binary search work? So first, binary search needs to, for example, sort the array first. So we need to change this 173 into 137. This is the first step, the sorting. And then we are going to like keep telling the Swift we need to keep looking until we found that specific target. So we will have a while or loop, for loop, and etc. In this case, I'm going to use while. We need a while, and in binary search, we could try to assume that maybe our target is in the middle. If it is, then return that target or return that middle number. Then, if it is not in the middle, then maybe we could check on the left side of that middle number. So if not, then maybe it is on the left side of middle number here. Then if not, then maybe it is on the right side of middle number, and keep looping until we are done. So we could improve this logic here. What is this not here? So if, for example, our target is smaller than the middle number, so for example, if our target is 1 and our target is smaller than the middle number here, so we could ignore this item and we could just focus in here, around here. So our left index is still there. We're not changing the left index, but we are changing our right index. The first right index is 7 here, but since we are only focusing in this, and maybe our value, our target is around here, then our right index we could change from the middle index -1, which is here. So the same thing goes with the if the target maybe is greater than the middle number. If it is greater, then it could be in around here. So the right index is still here, and the left index is changing from here to middle index +1. So it should be like starting here. So we are ignoring this case. So we could write this: if the target is smaller than the middle number, then maybe it's on the left side. And if the target is greater than the middle number, then maybe it's on the right side. So we could try, let's move here. Let's remove that and let's make the test failing. Great, we have a failing test, and let's go fix it one by one. So we are going to fix this one first, if it is on the middle, because it is matching in this case. So what we can do, we will have a kind of loop, and we are thinking about this. And for example, first we are going to loop until true, loop forever, but we can fix that. If that target is actually in the middle or middle number, then we can just return that middle number here, right? And let's run. And of course the middle number is not exist, and this one should be, our condition is still not there yet, right? So let's fix this because the compiler is complaining about this one. So what is this? we are trying to keep looping until our left pointer index, for example, the index that should be pointing here, is not overlapping with the right pointer index. Why is that? Because the way how binary search work is this left pointer index will getting closer to the right pointer index, because the index will move to the in the middle, and these two index will move to the middle. So once those two index passing each other, then the program should stop. Right. Okay, so we don't have this left pointer index. We could create this one. Left pointer index is equal to the very first index, and the right pointer index is equal to our sorted array. Remember that we need to sort the array, or sort number dot count minus 1, which is our very last index. What is our sorted number? It is actually array dot sorted here. Let's command you again, and let's see what things we can solve. This middle number, what is this middle number? It's actually our sorted numbers using s here on the middle index, right? Because we need the middle number. Let's command you again. And what is this middle index? Our middle index is the left pointer index plus the right pointer index divided by 2 here. So this should do it. And let's try to run and focus only to this specific test. So we don't need to worry about this test. We are focusing on this one first. What is this? I don't know. Let's try to run the test. Command U. Okay, seems like the test is not passing somehow. Let's try to run again. Great. We are passing in here, but somehow we are missing this case, right? So we could fix this. What is this test do? We should return nils when not found, right? So when I have like only one item of 1, and the target is 7, and it should return nil, right? Okay, this causing an infinity loop, I guess. So we could try to debug and let's see what happened. Is it going to pass here? No. So let's fix this. How to make this test pass? Should return nil when the value is not found, right? So this left pointer index and right pointer index will never be false, because we are not modifying this one. That's why our test is keep repeating indeterminately. So what we can do, this is actually a failing logic. What we can do, we can just try to continue to cover this one here. So what is this test? Should returns found number when found number on more than one array item. So we are targeting 7. 7 is on the right side after it is sorted, right? And should be return 7, right? So how to deal with this? Basically, we want to executing this logic here. So if the target is less than middle number, then what we can do is then maybe it's on the left side. Then maybe we don't need to do anything with the left pointer. What we need to do is moving this right pointer index on the left side, which is the middle index minus 1, right? And how about this one? If the target is greater than the middle number, then probably it is on the right side, which is we are not going to do anything with the right pointer index, but we want to modify left pointer index to become middle index plus 1. So I believe that should do it. Why don't we try to run the test? And yeah, we have a green test here. So everything is good. So I think we can commit around here. Let's commit binary search, implement binary search logic. So okay, I think that's all. how we can implement this binary search algorithm using test-driven development, step by step, one by one, dealing with empty array, and then returns nil when not found and returns items. So thanks all for watching, and let me know in the comment what you think about this one, and see you in the next video. Bye.